Alright, let me go over this problem. Planet Seeds intern claims that he can no longer complete the order because he spilled a cup of coffee on the sales ticket. Help Jack complete the order by determining the missing dimensions from the information that is still visible. Explain how you determine the possible unknown dimensions of each planter. So in a planner, give you a visual. This is called the base area. And the base area is basically length times width. And then, I'm just going to do it dotted. These dotted lines represent the height. So again, top there is your base. So all you essentially need for this problem is length times width. Everything down there. So all you need is the length and the width, which they've given you. They've given you the base area is 12. So there you have length times width equals 12. Well, what can you do with that information? Well, if I look back in my packet, we've been working on this problem of this box, and they tell you that the length, let's look back at our packet, our length is 18 minus 2x, and my width is 12 minus 2x. Then they tell you, well, that is 12. So what I can do is I can actually graph this. Notice how I'm not finding volume here. And then I can just find the intersection when I graph 12. So let's get my calculator. My old awesome calculator. Alright, graph at y equals. Put in 18 minus 2x. And 12 minus 2x. I'm going to put in y equals 12. And then I'm going to press zoom 6. My graph. Alright, can't see our graph. They told us before the dimensions, so I'm going to put that into the window. So I'm going to put in negative 10, 15. Y minimum negative 400, Y maximum 400. Now count by 100s. Okay, so I got that on page 319. Actually, you know what? Those dimensions are for the volume, and this was the base area, so I can just change my window. Let's go to 20. Alright, now I'm going to go ahead and graph the second function, which is 12. Which already has it in there. Let's see and it looks like it's very low, so let's check. Negative 5. Oh, I know why. My Y max is too high. Let's just say I go to 30. Like -1. Alright, so we're close. So I just need those points of intersection here. So on your Desmos graphing calculator, so on your quiz tomorrow, I'll probably let you, from one problem, take out your calculator, and you can use it to actually graph. And then here, I'm going to trace it. Well, if you had your smartphone, you could just click on that intersection, but for me, I actually have to figure that out. Left side, second one. So 5.21 is my x value, and then my y value is 2. So let's make a sketch of the graph. Something like this. That was 12. Different color. Graph's looking something like this. So this order pair is 5.21, comma 12. And let's go ahead and find that one. Over here, approaching 0, comes there, goes to there, goes right there, and my other order pair is 9.79, comma 12. Alright, so what does that tell us? It tells us that these are our possible heights. If I have a height of 5.21, then I get a base area of 12. If I use a height of 9.79, I also get a base area of 12. Now if I look at those two values though, I'm going to keep 5.21, but I'm going to reject 9.79. The reason why that I can keep, so let's write that, keep the height of 5.21 inches and reject, or don't accept, 9.79 inches because it is not in the range of interval notation 0 to 6, which means it has to be numbers 1, 2, 3, 4, and 5. Just not including 6. You can have 5.75, 5.99, but don't include 6. So that number reaches it, and this one doesn't. Remember, we did a table of values. Back in the beginning with the dimensions of this box, and we can pick any number 1, 2, 3, 4, 5, 6, up to 7, but we looked at 7 and it has a negative volume. Alright, can you imagine buying a can of Coke or a bottle of soda and it holds negative volume? It doesn't make sense, right? 6 doesn't hold anything, so I can have 5 that holds something, and then 5.21, which we just found, is actually going to hold something. So, when you're using your box, let's draw a box. And then if I have 5.21, and this is 5.21, I need a value called x, right? 5.21 plus x plus 5.21 is going to be 18. Well, if I just subtract 18, or 18 minus 5.21, we double that, it's 42, and then I have 7.58. So my height, if it's 5.21, then my length is 7.58. If I do the same thing going this way, 5.21, 5.21, and this is y, and then this length has to be 12. So from 12, I'm going to subtract 10.42, and I get 1.58. Right? If this is 1.58, and you add up those three numbers, you'll get 12. If this number is 7.58, you add up all those values, you get 18. And if you multiply all three numbers together, you'll get your volume. And it gives us a volume of 62.4. Now if you think about it, that actually matches our chart. 5.21, it's a little bit more than here, and it's going to be between 80 and 60, or 80 and 0, so there's like 62.4. question number 8. Customer sent the following email to whom it may concern. I would like to purchase several planter boxes, all with a height of 5 inches. Can you make one that holds 100 cubic inches of dirt? Please contact me at your earliest convenience. So they're asking, if my height is 5, can I get a volume of 100? So we draw our picture. Here's 5. Here's 5. And this, we're using that same piece of sheet paper, right? It's 18 inches long. So 5 and 5, that's 10. So that means this has to be 8. So that means my length here is 8. My height is 5. So if I go this direction, this has to be 12. So 5 plus something plus 5 equals 12. Well, that means that my width has to be 2. Well, if your volume is equal to height times length times width, and my height is 5, my length is 8, and my width is 2, then I get 80 with a height of 5, with a height of 5 inches. The max volume is 80 inches. So dear dear customer Jenkins, thank you for responding. With a height of 5 inches, the max volume is 80 inches. We cannot build the planter box with 100 cubic inches in volume from a 12 by 18 sheet. Right? Because we're saying max 80 and she wants 100, so it's not possible.